When you need to travel a great distance, such as from one continent to another, you book a plane flight and anticipate being in the air for several hours. When it comes to space travel, though, you must move more quickly because all of the points of interest are so far away. Space explorers have always been on the lookout for a technique to travel faster than light in order to reach deep space faster. All of the methods revealed so far have serious flaws, but scientists have discovered a new way. What is the mechanism behind it? What are the conditions? When will you be able to use it for travel? Join us as we introduce you to a new mode of travel that is faster than light. Light is fascinating and crucial since seeing this video would be tough without it. We can walk without running into items unexpectedly thanks to the sun and various artificial light sources that humans have devised. However, you've probably heard that light travels quickly. But how fast does light travel? Surprisingly, the exact speed of light is known and serves as the foundation for most other calculations. The speed of light in a vacuum is 299,792,458 meters per second, 983,571,056 feet per second. In a single second, the light will travel around 186,282 miles. Light travels so quickly that if you turn on a light bulb in a dark room, the light covers the area almost instantly, and you won't even notice it. The light year, which is the distance that light can travel in a year, is another unit of measurement that involves light. This figure is approximately 6 trillion miles, 10 trillion kilometers. Astronomers and scientists use it to measure vast distances across our cosmos. As previously said, the universe is so enormous that light can travel thousands of years from one end to the other. For example, light travels from the moon to our eyes in about 1 second, implying that the moon is 1 light second away. Sunlight, on the other hand, takes longer to reach our eyes, taking roughly 8 minutes to reach our eyes, implying that the sun is about 8 light minutes distant. The light from Alpha Centauri, our nearest star system, takes 4.3 years to reach us. Hence, Alpha Centauri is 4.3 light years away. Other stars and things outside our solar system can be found at distances ranging from a few light years to a few billion light years. This is why what astronomers see in the far reaches of the universe is history. When they investigate distant objects, they perceive the light that depicts the objects as they were at the time the light left them. Scientists have sought to develop a means to move at the speed of light, despite the fact that there are many exciting things you can do with light. This is fascinating since humans will soon be an interplanetary species. For example, Elon Musk, the wealthy CEO of SpaceX, wants to establish a civilization on Mars. But his explorers will have to endure at least 5 months of spaceflight before touching down on the red planet. Depending on how close the two planets are, this might last up to a year. And that's before it ever lands on Mars, with all the dangers it carries. They can, however, complete the journey in less than 4 minutes thanks to the speed of light travel. Researchers have experimented with a variety of approaches to accomplish high-speed transport. However, there was always a problem that no other approach could fix until a scientist presented the new discovery we'll show you in this video. It's difficult to accomplish even 1% of the speed of light, which is still very fast because it can transport you from Los Angeles to New York in less than a second. In a single word, the issue is energy. The motion of anything generates energy, which physicists refer to as kinetic energy. To travel quicker, you must increase your kinetic energy. The issue is that increasing speed requires a lot of kinetic energy. It takes 4 times the energy to make anything go twice as fast. Increasing the speed of something by 3 times necessitates 9 times the energy, and so on. To accelerate a 110-pound teenager to 1% of the speed of light, for example, would require 200 trillion joules. That's about the same amount of energy as 2 million Americans use in a single day. Consider the EM drive, which was built as a technology that would whisk humanity to the farthest reaches of the cosmos in record time. Theoretically, this patent-pending technology works by trapping microwaves in a shaped chamber, where their bouncing produces propulsion. The chamber is closed, so it will appear to move without any fuel input or thrust output from the outside. The EM drive is based on Newton's second law, which states that force is defined as the rate at which momentum changes. As a result, an electromagnetic or EM wave moving at the speed of light has a certain momentum that will transfer to a reflector, producing a little force. The EM drive, which sounds simple but actually turns our understanding of physics on its head, is enabled by this accumulated small force in large quantities. There is no energy moving in or out, which leads us to wonder how the waves begin to move, how they continue to move, and where their impetus comes from. Without an explainable push, you can't have spontaneous, produced momentum, which is why many scientists dismiss the EM drive. If the EM drive works, it will debunk a lot of what scientists think they know about the cosmos. Physicists from the Dresden University of Technology even put the EM drive to the test, revealing that the optimistic results obtained by NASA and the Chinese, demonstrating thrust, were all false positives caused by extraneous forces. However, as Dr. Eric Lentz, a physicist with over 10 years of expertise in practical applications, has demonstrated, the warp drive holds immense promise. Not only was Lentz not the first to work on making the warp drive a reality, but he wasn't the only one. Miguel Alcubierre, a Mexican mathematician, was the first to attempt it. His suggestion, which was published in 1994, marked the beginning of the official literature on warp drives. Unfortunately, the so-called Alcubierre warp drive necessitates a massive quantity of energy, as well as the dreaded exotic matter as a co-ingredient. This highly radioactive substance is simply a theory. It has never been observed in nature, let alone synthesized by scientists. Since then, a few variants have been proposed, including a 2010 update to the Alcubierre drive's physical design by Dr. Harold G. Sonny White, a former NASA engineer. His revision reduced the required energy to a more manageable level, yet it was still impractical because the method still required exotic matter, albeit in fewer quantities than the Alcubierre system. Another group of Swiss researchers, known as Applied Physics, or APL, proposed their own idea. Surprisingly, their drive's warp bubble was created without the use of any unique materials. Their model, however, was unable to move faster than the speed of light, which is the holy grail of space travel. To demonstrate how his approach differs from others already offered, Lentz begins by describing the physical structure of the classical Alcubierre drive, which is the foundation for practically all other solutions. The Alcubierre method, he claimed, gave an intuitive message of what a warp drive would do: constrict the space directly in front of the center region housing the ship or vehicle, and expand the space immediately behind it. This depicts the warp drive as a curved wave that a spacecraft will ride to its destination on. Despite the fact that it is the cornerstone of warp travel, Lentz contends that it is not even the most important aspect. Instead, he claims, physicist Jose Notario's answer from 2002 demonstrated that the expansion and contraction were not required to move the ship ahead. That work led him to reconsider how a warp drive may be formed using simply ordinary matter, rather than unusual materials. Notario was able to show that the expansion might be trivial or zero everywhere, and yet move a ship. This is a big accomplishment because it eliminates the necessity for exotic matter, which warps the space in front of and behind the theoretical passenger in practically all theoretical warp drive methods. Lentz produced his own variation based on Notario's idea, which he says is even more realistic because it is based on common physics. Apart from the material difference, Lentz claims that his solution differs geometrically from Alcubierre's and most others because of how the energy is distributed across the warp bubble. The energy density and curvatures are maxima separated in the Alcubierre solution, with the energy constrained to a tiny torus between the zones of intense contraction and expansion. In Lentz's proposal, the curvatures and sources are highly connected, with the regions of high energy density and high expansion and contraction virtually exactly overlapping. Because of the geometric difference between his concept and existing concepts, Lentz's approach could be a more practical warp solution than those previously offered. Of fact, Lentz's warp drive is still just a concept. He does, however, see a few immediate measures that may be done to bring his version closer to reality. One of which, like all previous drive hypotheses, is to reduce the amount of energy required. From here, where does Lentz plan to take his warp drive? The next goal, he said, is to use a modern-day fission reactor to create a warp bubble capable of traveling at 1% of the speed of light. The physicist stated he'd explore patenting his warp drive, but he made it plain that his work is just one piece of a broader, quickly developing body of work in this field, and that the recent spike in new warp drive concepts since the year 2000 is a result of that. Alcubierre's suggestion from 1994 gives encouragement to those working in this field that an actual, testable version is closer than we realize. It's been exciting to see how much progress has been made recently on the subject of warp drive. According to Lentz, he believes that many more advancements are possible, and he looks forward to seeing what the next several years bring. Let us know your thoughts on the warp drive that can travel with the speed of light in the comments box below. And thank you for watching.